In this video, we're going to go over the string and bytes methods, operators, and functions to give you a sort of complete picture of what you can do with string and bytes in Python. I'm not going to go into any great deal on any of these topics, but you can always, of course, refer to the Python documentation for more details if you need it. First, a bit of terminology. You might have heard of something called a char or a character. Python doesn't have a special type for chars or characters. And for a string and a byte, it's going to mean different things anyway. So this is just a length one, string or byte. Bytes, I should say properly. And so for a string, it's going to be a Unicode code point. And for a byte, it's going to be a number between 0 and 255. So let's review or go over really quickly the operators, all of the operators that I can think of that apply to strings and bytes. First, let's go over the comparators. First, bytes and strings don't compare with each other. So you have to compare with the same type, okay? So you compare strings with strings and bytes with bytes, but you cannot compare bytes and strings together, okay? The order is alphabetical. If you don't know what that means, that doesn't matter. It just, there is an order and it's important. One note about alphabetical is that if all the characters compare the same, then the shorter string will be the one that comes first. So like for instance, if you have AS, this is going to be less than ASDF. Okay. The first two characters in the string are the same, and so this string is before that one because it's shorter. Okay. The next one that I want to talk about is the is and is not comparator. This is testing for identity, it's not testing for value. And so typically you don't want to use this for strings and bytes because strings and bytes, even if they're the same string or byte, it's highly unlikely they're actually the same string or byte. So you want to use the equality comparator instead. So use equals or not equals. This will look at each character and make sure they're the same. If you are comparing the same string or byte with itself, it'll know. Okay. So we also have membership tests for the operators. So that is x in s, okay? And what this tests is that x is a substring of the string or bytes s, right? So you can say like, is as in the word has? And the answer is yes, as is in has. And of course, there's also not n, which is the inverse. You can say not x in s or not x not in s. I prefer this x not in s version. You can do concatenation. I'll abbreviate that as concat. So this is when you take two bytes or strings and you add them together like this. And they must be the same type, so you can't add bytes to strings or vice versa. And what this does is it produces a new string that is basically the string st pasted together like that. So an example of that would be ABC plus DEF will give you ABCDEF. Note that in Python, if you have two string literals, one right after the other, or byte literals, you do not need to put the addition operator. It will automatically concatenate them for you. So this really only applies if you have an expression that renders a string. Also, if you're doing this a lot, you probably should use join. It's called quadratic behavior. It's very slow to add many strings together in this way. Okay. Next, let's cover multiplication. I guess that's number 4. I shouldn't number things. You have s star n or n star s. N is an integer, and s is a string or a byte. A string or bytes. And what this does is it adds s to each other, it's to itself n times, right? So basically multiplies s. Obviously, it doesn't add them like this. It'd be quadratic, but it does it very quickly. Okay. I actually use this occasionally, especially when I want to have like, I'll do something like dash star 4, and that'll give me 4 dashes. We also have subscription. This would be s, where you pass in some integer I with square braces, and this will give you the ith element. Remember, it's 0 based, so the first element is 0. and 1 is second, and so on. So it's a little bit confusing. So just say the ith element, okay? the 0th element, the 1th element, we say it that way so we don't confuse ourselves. You can, of course, use negative numbers. So, for instance, s of -5. And what this does is it adds this negative number to the length of the string. So this is going to be the same as s of the length of the string minus 5. So it's basically 5 from the end. Note that when you're doing this for bytes, this will give you an integer, not a byte. Okay, so it'll give you the integer value for that byte. We're not talking about slicing yet. We'll cover that when after we cover tuples. Slicing is a very powerful feature of Python. We'll be hinting at slicing though, so you'll see some things in here that suggest slicing, but is not in fact slicing. Let's go over the built-in functions. These are functions that Python has that you don't have to import. It's available all the time. The first function is str. So str takes a parameter and it will return a human readable string. If it can't find a human readable string, then it will return repr instead. Speaking of repr, what this returns is a Python readable version of the string. For instance, repr of 1.5 should give you 1.5, the string 1.5. So you can run this in a Python interpreter, it'll give you 1.5 back. Now if it can't do that, then it will give you something with like angle braces. And you might have seen this before in your Python interactive mode. It'll say like something as an angle brace, especially when you do something like range. It'll give you angle braces. That's what repr will give you. Of course, we have bytes as well. Bytes can actually take up to 3 arguments, including the encoding and the errors. I'm not going to cover that version though. I'm going to put sources here, or source rather. Source can be a string or something like that. It'll pretend that it's ASCII. It can also be a tuple of numbers. So this is, we haven't covered tuples yet, but I think this is interesting enough it deserves to be pointed out. So you can say bytes of, let's say 10, 155, and 218. And we'll use parentheses around that. So it'll take a list of integers, or an iterable of integers. We have chr, chr, which takes, a single element, a character, and will return a number. I don't know what s is, but it will return some number. And then if you do OR and you take some number, I know that octal 101, for instance, will give you the capital A. Okay. Note that int will actually take a string. So you can pass in a string to int, and it'll interpret this as decimal. So for instance, int of 11 as a string will in fact give you the integer 11. But you can also pass in strings of different bases. So you can s comma base. Okay. So if I did int of, let's say, 17, comma base 8, that will give you, let's see, 8 plus 7 is 15. Okay. And of course you can do insane bases, like you can go, I think, up to base 36. So you can use the letters A through Z like you would for hexadecimal. So you can use all kinds of different bases if you really wanted to. Very interesting, fun use of int. Float can also take a string. Okay, that string must be a valid float, one form or the other. Complex can take a string. If you have a plus in there, you can't have, there's no spaces allowed. So for instance, 3 plus 4j is fine, but 3 space plus space 4j, this will be an error. Okay, I think it's a value error. Bool of a string. So the empty string is false. What does an empty string look like? That's just, quotes with nothing inside. And everything else is true. All right. We can also do a function called input. This is a fun one to do. Give this a try. And you can specify some kind of prompt. And what this will do is it'll prompt the user to type in input. So I typically like to do something like this. So I'll do input and I'll put a question mark space, or you can use an angle brace or whatever you want to do in there. Okay. And you can collect input from the user. Of course, there's len, L-E-N. It'll tell you how long something is. Max and min. You can pass in a string or a bytes there. It'll tell you the largest or smallest element of that byte or string sequence. And of course, we also have print. Okay, so you can actually print with multiple parameters. You can include strings and stuff like that. It'll print it out for you. All right. Print has two named parameters you might be interested in. One is sep. Sep equals, and I think by default it's a space. And the other is end. And that is \n. So sep, if you have multiple parameters to print, sep will put the separator between those elements of print. And end is the new line that you want to use, right? So typically you might want to put sep equals to a comma space. Okay, and then you can print multiple elements out. Well, let's talk about the methods of string and bytes. We haven't really talked about what methods are. We're going to cover that in detail in object-oriented programming. For now, these are just functions that are part of the object itself. Think of it that way. Note that bytes take bytes in their parameters, and strings take strings. So if you're calling a byte method and you pass in a string, it's going to tell you that's not appropriate. I've grouped these methods by kind of theme. So I don't know if this scheme is proper, but this is what I came up with. So the first one is membership. These are functions that look at what's in the string or bytes and tries to figure out like where it is or how many there are, things like that. So most of these take start and end as optional parameters. Basically, this is if you took the string or bytes and you broke it up into a substring starting at start, so I'll put square brace start, and then going up to but not including end, and then this membership test will only be for that range. Okay, so we have count, so we have s.count, and we will have some kind of substring in here, and this will have a start and end optional. And this will return how many times that substring occurs within that area, or the whole string if you don't specify it. This also works for bytes, of course. So I'll put b/s. Okay. You can also, for bytes or strings, you can do index. Okay. And you specify some substring, and again, start and end. And what this will do is return where the substring starts. Okay. For instance, if I did ASDF.index and I'm looking for SD, then this will return 0, 1, because 1 is where the SD starts. Okay. Note that if it doesn't occur, it will raise a value error. Okay. There's also R-index. So b/s R-index, same parameters. And what this does is it starts from the end and goes to the right and looks for it. Okay, so if it occurs multiple times, it'll give you the rightmost one. There's a lot of R methods in these things. There is also b/s find. You're looking for substring, start and end. The difference between find and index is this will return -1 if not found. It won't raise an exception. Some people use find to test to see if the substring is inside of the string, but that's really not proper. You should use in or not instead. But if you really want to, you can go ahead and use this. Okay, there's also rfind as well, which does the same but goes from the right. And there's two more functions that I really enjoy, that I use these quite often, you'd be surprised. And this is for both bytes and strings. You can do start with, and you have the prefix, start and end. Okay, and this checks to see that the string starts with that. Okay, and then there is also ends with, I get these confused. I always have to look them up because I forget how to spell them exactly. Other languages have similar methods. This is a suffix, I'm sorry, suffix, start and end. Okay, here's an example. How do I use these guys? Well, I might say, like, you know, you have some image like colors.jpg, and you might want to see if that ends with .jpg. Okay, and if it does, then it's true. If it doesn't, it's false. Very useful. The next group of methods I want to look at are the splitting and joining methods. They go hand in hand. Of course, there is, you can use for bytes or strings, the join method. And what this does is it takes some iterable, and it creates a new byte or string using the byte or string as a separator, right? So this is a very useful function. I use it all the time, literally like all the time. I use it more often, I think, than concatenation with the addition operator. There is partition. This takes a separator. And there's R partition as well. What these do is this looks for the leftmost instance or the rightmost instance of separator and returns the before, the separator, and all the rest after that. So these do the same thing. It's just which direction they're looking from. If it can't find it, then it will return the whole string or bytes, and then none, and then none. We haven't talked about tuples yet or parallel assignment. We'll cover those later. There's also split. And you can have a separator, and you can have a max split optionally. I think this defaults to -1. And there's also R split. Sep max split equals -1. And what this does is it takes a string and it breaks it up into multiple substrings based on where the separators are. And I think by default it uses white space. So if you don't even specify a separator, it will use white space to separate things. And so it returns it as a tuple. And we haven't really covered tuples yet. The only difference between these two is if you have R split and the max split is not -1, then it'll give you the rightmost splits. Okay. And finally, there is split lines. And you can specify whether to keep the ends or not. By default, it won't. And what this does is it returns a tuple of the string or the bytes split into lines using new lines or other kind of line separators as line separators. Of note, /v and /f are also used as line separators. And there's several Unicode line separators as well that it uses. Well, let's talk about stripping. Stripping is removing characters from the end or the beginning. There is bytes or string.strip. And so you can have a class of characters you want to specify. If you don't specify, it's going to strip white space. And this will return a new string or bytes that doesn't have the stripped characters at the ends. And there's also lstrip and rstrip. Lstrip strips only from the left, and rstrip only strips from the right. You should always use strip on user input. Always, always, always. This one right here. There's capitalization. We have, you can use bytes or strings, you can do capitalize. And what this does is returns a new string with the first character is uppercase and the rest are lowercase. Okay. There is, and this is important, there's case fold. Okay. This only works for strings, by the way. s.casefold. And this will return a lowercase. Plus, it'll convert things like the German, it's the double S basically. It'll convert that to 2 S's so that you have a consistent case folding. You can look, you can revert to section 3.13 of the Unicode standard to understand what case folding is used for, to understand how case folding works. But what this is used for is if you want to uniquely identify strings regardless of case, you want to use the case fold to reduce it down to a set of characters that can be used to uniquely identify each, capitalized or alternative version of the same word. There is also lower, which you can use on bytes or strings. Lower will return a lowercase version of the string. All the characters are lowercase, right? And this was used historically for, uniquely identifying the strings. But in the Unicode world, you really should be using casefold for strings. You can still use lower for bytes, though. We also have swap case, which switches the cases, as you might expect. And we also have upper, which moves them all to uppercase. There's also sb.title. That's right. You can take bytes or strings and title them. And what this does is the first caseable characters in a segment, it goes uppercase, and the rest goes downcase for each word. This is title case, for instance, and there's spaces in between. Okay. There are a bunch of methods regarding testing whether or not the characters in the string or byte is a particular class. And I'll just kind of list them out here really quick. We have is alnum. This tests to see if it's an alphabet or a numeral digit of any kind. There's is alpha, which tests to see if it is a letter. The Unicode defines what letter is. It's pretty obvious what it is in the ASCII character set. There's is ASCII, which tests to see if it's valid ASCII. Is decimal. Note that ASCII only goes from 0 to 127. That's 0x00 to 0x7f, right? Is decimal tests to see if it's a decimal digit that can be formed to, pass into int or something like that. There is digit, which tests to see if it's a digit or decimal in Unicode standard. There's is identifier. This tests to see if it's a valid Python identifier. Is numeric. Test to see if it's a numeric. Is printable. This tests to see if each of the characters are actually characters or if they're white space. If they're white space, they're not printable, except for, oddly enough, the space is okay. So that's a kind of weird one. Then you also have is space, which tests to see if it's white space. Then we have is lower to see if it's all lowercase, is upper, and is title. These test the case of the characters. Note that most of these all return false for empty strings. If I can spell empty, E-M-P-T-Y. Some of them will return true. I think is ASCII and a couple others will return true. I think is printable as well. You have to check the documentation to make sure which does what. Now we have alignment. I have rarely, if ever, used these in my professional career. This includes center. So bytes does string to center. And you specify the width. And you can override the fill char, which defaults to a space. And there is L-just and R-just. And what this does is it takes the string and aligns it inside of the width. In this case, it'll center it. These have the same parameters, I should mention. And they take the same bytes or strings. And this will basically align it inside of that space. When you get into formatting, there's some functions in formatting that can do this as well. And there's also, for bytes or strings, you can do expand tabs. And you can specify the tab size, which defaults to 8. And what this does is it takes a string and it looks for tab characters. If it sees a tab character, it counts the number of characters used before the tab character and then adds an appropriate amount of space so that you will get a string with spaces instead of tabs and everything lined up. Okay. There is stuff for encoding and decoding. So you can take a string and you can encode it, specifying some encoding. And you can take bytes and you can decode it, specifying some encoding. And so the string will give you bytes, and the bytes will give you a string. We will cover this in much greater detail when we go over Unicode. You can format strings, which we're going to cover in a separate video. So that's s.format, only strings can be formatted. And there is s.formatMap. I'm not even going to mention how these work, I'm just going to mention that they exist. You can also use for bytes or strings, you can use the replace method. What you do here is you specify the old and the new, and you can specify optionally a count. And so this will take all substrings old and replace them with new. And there's also something called zfill, which you specify a width. And what this does is if the string is like a number type, it will put zeros in. And if it starts with a plus or minus, it'll keep in this plus or minus to make the string that width. Okay. And there's two more that I want to cover. One is you can specify str.makeTrans. You can also do this for bytes. This will create a translation table that you can use on a string or bytes. You can say translate with that table that you just built. So these return a table. I have never used this except to experiment and learn about Python. I don't really know what this is used for except for things like ROT13 encodings. ROT13 is basically replacing each alphabet letter with another alphabet letter, and you're rotating through the alphabet. And oh, one more thing about bytes is you can do b.hex, and this will return a string that has a pair of hex for each bytes. And you can also say bytes.fromHex, given some string. And if that string is a series of hex digits, you can have white spaces, okay, but if it's a series of hex digits, it'll translate that to a string of bytes. So that's all the methods and all the functions and all the operators I can find that have anything to do with string and bytes. This is a slightly long video, I think, but it's okay. If you have any questions or if you want to learn more about these, you can refer to the Python documentation, or you can ask in the comments below, or you can join me in Discord, of course. Guys, thanks for watching this video. Thanks for your support. Take care. Bye-bye. Thank you for watching this video on the theory of Python by Real Physics. Be sure to subscribe and ring the bell, like and share this video. You can find me on Discord or support me on Patreon. Links are in the description below. Thank you so much. Have a great day. Bye-bye.